Hey, you guys, I'm excited to do another lecture today for the last gas law that we're going to be learning this year. So super exciting. That does not mean that you are done learning altogether. It just means it's the last new gas law. Okay, so this is the ideal gas law, and you can see the expression on the screen. It's PV equals nRT. This is the first gas law that we've talked about that deals with something other than just pressure, volume, and temperature. There's two new variables here, and you can see that N and R. N is the number of moles, okay? So, but that's what that is. Not a whole lot new to that, except it's just the number of moles. R is a special constant just for the ideal gas law. So if you look at R, it can have two different values. It can be 8.31 kPa times liters per mole Kelvin, or it can be 0.821 liters times atmospheres per mole Kelvin. So either of these expressions can be used for R. You just tend to use the one that matches the unit of pressure that you need. So that's pretty much it. Write down those constants for sure in the expression. Okay, so let me see if this is, I love this law because it involves the amount of gas present, which the other gas laws didn't, okay? The other cool thing about this gas law is that we're just talking about a set of circumstances that do not involve change. So there's no initial and final. This is all just in one circumstance, okay? So let's read this problem. A deep underground cavern contains 2.24 times 10 to the 6 liters of methane gas at a pressure of 1.50 times 10 to the 3rd kPa and a temperature of 315 Kelvin. How many kilograms of methane does the cavern contain? So what we're looking for is actually we're going to find number of moles and then convert to kilograms from there. So we know our pressure, we know our volume, we know our temperature. We're going to use the value for R that has kPa in it. So I'm going to flip back just for a second. Remember how there were two different values for R? I'm going to use the one that has kPa associated with it. If I had atmospheres in the problem, I would use the alternate value for R. All right, so we're going to use 8.31. And then we will also need the molar mass for methane down the road. So first of all, I'm going to solve for moles. So I'm going to do PV divided by RT. I know this looks like a lot on one slide. Just take it a piece at a time, you guys. And I'm going to solve for moles. PV divided by RT. Plug in those values, okay? PV, RT. And then multiply across the top, divide by the bottom numbers, round for sig figs, okay? And you have moles. Now, we were asked for kilograms of methane because I don't know if you know this, moles, the concept of moles is pretty much limited to chemistry. Whenever you're talking to people in industry, they don't go, you know, I'd like to buy 700 moles of methane. They go, I'd like to buy this many kilograms or this volume of methane. So we need to convert those moles into something that's more user-friendly, you could say. So you take moles and you multiply by the molar mass of methane, and that gives you grams. And then you divide by 1,000 to get you kilograms. These last two steps, we're not going to do so much this week. We're going to do pretty much just straightforward dealing with PV equals nRT. So this top section of this example problem, if we were in class, we would be doing a lot more of these kind of two-step problems, but alas, we are not. Okay. Now, this week, instead of doing a lecture video at the beginning and a review video at the end of the week, I'm just going to combine the two. So I'm going to go ahead and take you through one of the problems on your worksheet. So we're going to look at question 1 on this week's assigned worksheet. And then if you have questions beyond that, of course, reach out to me via email like you guys have been doing, okay? So looking at question 1, I would always encourage you to write down the formula for the gas law you're dealing with and then identify your variables as always. We talked about earlier how there are two different R values. I would also write those down on top of your paper. Typically, there's going to be a test situation, you would be expected to know all of these formulas and you would be expected to memorize the different values for R as well. Obviously, this is a different scenario, but writing them down repeatedly helps you to memorize them. So something I would encourage you to do, because again, those of you going on to AP, those of you going on to college chemistry will need to know this. Okay, so let's look at question 1. So please go ahead and have that out in front of you. What pressure is required to contain 0.023 moles of nitrogen gas in a 2.4 liter container at a temperature of 20 degrees Celsius? So we're gonna take a look at this. They say right off the bat what pressure is required. So we know we are looking for pressure from the very beginning, okay? And then let's see, the next thing they give us is 0.023 moles. So that's N, 0.023 moles. And let's see, of nitrogen gas. Here we don't need to know anything about nitrogen. There are some questions, again, not on this worksheet necessarily, but like if we were in class, you would need to know the molar mass of nitrogen to convert to grams at the end. But again, we're not going that far right now. In a 4.2 liter container, that's my volume, at a temperature of 20 degrees Celsius, again, need to convert to Kelvin. So 20 plus 273, 293 Kelvin. Now we're going to choose our value for R. I already had these written down for you guys, but we're going to choose which one we're going to use. Look at your pressure. Oh, wait. Okay, there isn't a unit of pressure because we're looking for pressure. Now, if the question had asked what pressure in atmospheres, what pressure in kPa, you would be stuck using one or the other of these. I tend to use the 0.0821 when I have a choice. In this case, you have a choice. You can pick which one you use. Just make sure the units on your final answer are correct, okay? I'm going to choose this one because I just like atmospheres better. I don't have a rhyme or reason for why, I just do. So I'm going to choose the 0.0821 value for R. And then I'm going to rearrange my equation to solve for P. So it's going to be P equals nRT over V. A lot of times students struggle with this because they always want it to be a 2/2 situation, like the example that was in your notes. It was like PV over RT. It's not always 2/2, okay? It's 2/2 or it's 3/1. That does not matter. You just need to rearrange and solve for the correct variable, okay? We're going to plug in those values. N is 0.023 moles. I'm going to abbreviate that MOL. Remember, that's the abbreviation for moles. 0.0821 liters times atmospheres per mole Kelvin. I know you can't see that from there. I know there's no chance you can see that from there, but it's these units that I'm writing, okay? We're going to talk more about the purpose of those units in just a second. And then 293 Kelvin. I am running out of space. I'm going to put 293K right here, but in a perfect world, it would just go right here next to our value for R. Try to give myself more space on the next one. Divided by 4.2 liters. Okay. Now here's where students go wrong. They think that the units on the constant R are supposed to be variables they plug into. Liters times atmospheres per mole Kelvin are just the units. And the purpose of those units is to cancel whatever can cancel, okay? So for example, liters appear down here and on R, okay? Moles appear in both places. Kelvin appears in both places. So the only thing that doesn't cancel on the units on R are atmospheres. So our final answer will be in atmospheres. Whatever unit is not canceled out from your R value, that's going to be the unit on your final answer, okay? So don't get too caught up in getting confused about the units. Just write them down, cancel whatever cancels with them. Whatever doesn't cancel, that goes on your final answer, okay? Multiply across the top, divide by the bottom, and we should get 0.13 atmospheres, rounded to 2 sig figs because 0.023 has 2 sig figs, okay? Hopefully that's not too much of a leap from last week. Let me know if you have any more questions and I can do some more example problems if you need me to. Have a great day, you guys.